my average velocity. Not 9.
10.
Not 10. You can add up the 11 numbers and then divide by 11. Or just add the first and last. Five. I better cap this before I draw board with it. So my average velocity is 5 meters per second, so negative 40 plus 50 is 10, divided by 2 gives me 5. My displacement is just my average velocity times time, which was written up here. My displacement is average velocity times time, which is 5 times 10, 50 meters. All right, time to stop. Let's at least get that far and then we will stop. This is why this one's a more difficult problem than the other one, the fact that I don't hit 0. My velocity is not 0 in any second. It's going to be somewhere in between. But I do know it's going to stop between which 2 seconds? When is the velocity 0? Between what and what times?
5 and 6.
Yeah. I know it stops when velocity is 0. Can't use the finger for this one. So it's going to be somewhere in here. Matter of fact, it's going to be closer to 5 than it is to 6. Because that's closer to 0 than that is. The way that you would solve it, again, using this, I'm going from negative 40 to 0. So my change is negative 40. Over my time, which is what I'm trying to figure out, is going to be equal to, oh wait, sorry, my change is positive 40. Negative 40 to 0 is positive here. So 40 divided by time is equal to 9, which is my acceleration. Or in the math problem, 40 over t is equal to 9 over 1. That's the math problem. Solve for t. If I got 2 fractions equal to each other, I multiply the diagonal I know, divide by the number left over. So the final time will be 40 divided by 9, which is 8. Something's off.
I think you missed
a
four there.
number, yeah.
This one, so
0 to 40, 1 to negative 31, 2 to negative 22, negative 13, 4.
You don't have a number for 4?
Yeah.
the, oh.
Yeah.
There. Okay, yeah, sorry about that. It's gonna be between 4 and 5. And we get 4.36, 4.4 repeat seconds. That is the time it took the car to stop. And that is the time that we were going to stop. Monica, you have a question?
Yes, I was stuck on like trying to figure out what was wrong with that, so I completely missed that very last problem.
Oh,
Here, you just go back over it for me.
yeah.
So we are looking for,
Plug it into this equation, and know my acceleration is not given in the problem. My change in velocity, I go from negative 40 to 0. That's a positive 40 change. And positive 40 divided by the time must be equal to 9.
okay,
So that's the math problem.
40 over t is 9
Yeah. So I multiply the diagonal line of 40 times 1, and divide by the number left over. So that's 32 over 9, which I believe is 4.4. forward.
Okay. Thank
So basically where it turns like, before it turns positive, you go.
Yes. When it changes sign, when the velocity changes sign, I know zero has to be in there somewhere. In this example, we happen to hit zero at 1/2, at a nice spot there, make it easy. But sometimes it doesn't.
Oh, so whatever it is, where is it?
Yeah, so average acceleration is change in velocity over change in time, or change in velocity over time. But because the acceleration is constant, the average acceleration at any point is the same.
Where did we get the 9 again? 9.
Given in the problem,
Oh, 9 years, okay.
I would just do it. I don't know if that's
which does bring up, if on a test, you ever see a gift icon next to the problem, that means the answer is probably written in the problem. So if I start, my first question had been, what's the acceleration? I should put a gift icon next to that, just so you know, wait a second, I don't want to overthink this.
Yeah.